Children, welcome to Math Park. Our today's topic is area theorems from the book Concise Selena, class 9 ICSE. In this, we are going to understand the proofs on area theorems and understand how it is being used to solve the problems from exercise 16A. So this video is going to be done in two parts, children. So if you like it, please share with your friends. And if you are new to the channel, please subscribe. So the figures between the same parallels. So you can see that here AB is parallel to CD. These are the two parallel lines. And there are some figures. You have a parallelogram here, you have a rectangle here, and you have a triangle there. So all of these will have same height because the perpendicular distance between two parallel lines is always same. So the height of a triangle will be same as the height of a square and same as the perpendicular height of a parallelogram. So the basic concept before we start with this chapter is you should know the formulae for the area of triangle. So you have area of triangle is equal to half base into height. So where this is your base and this is your height. Area of rectangle is equal to length times breadth. And area of parallelogram is equal to base into perpendicular height. So QR is the base and perpendicular height. So what we understand here that obviously that the parallelogram, the rectangle and a triangle between the same parallels will have equal height. Got that? So the first theorem, that is theorem 19 in your book, it says parallelograms on the same base and between the same parallels are equal in area. So what is given to you? You are given parallelogram ABCD. ABCD is the parallelogram and ABEF is a parallelogram which is on the same base AB. The AB is the common base for them and they are lying between the same parallels AB and DE. You have to prove that area of parallelogram ABCD is equal to area of parallelogram ABEF. So let's start with the proof of this. For proving this, now we will be proving these two triangles congruent. In triangle ADF and triangle BCE, you have AD is equal to BC, opposite sides of parallelogram. They are opposite sides of parallelogram. Then we can number the angles here. So you have angle, this is D. So you can say that angle 1 is equal to angle 2. Angle 1 is angle D of this triangle. So angle 1 is equal to angle 2. They are corresponding angles. And also you can take this as angle 3 is equal to angle 4. So you have angle 3 is equal to angle 4. Both of these are corresponding angles. Naming the angle saves your time. They are corresponding angles. So it saves the time, instead of writing the complete name, you can number the angles. And therefore, you have triangle ADF is congruent to triangle BCE by angle side. So this is your angle by this angle, and the side. Got it? So this is how these two triangles are congruent. Now, if the triangles are congruent, their areas are equal. So therefore, you have area of triangle ADF is equal to area of triangle BCE. Area of BCE. If the triangles are congruent, their areas are equal. Here we have, this is the common quadrilateral. Okay. If I add area of ABCF to both. So add area of ABCF to both sides. So we get area of ADF plus area of ABCF is equal to area of BCE plus area of ABCF. Now, the area of ADF plus this ABCF gives you area of parallelogram ABCD, and area of this triangle plus this common quadrilateral ABCF gives you area of parallelogram ABEF. Thus, we have done with the proof of theorem 19. Got that? Triangles by AAS. Congruent triangles have areas equal, and just added this common part. Our first theorem is done. Now, there are corollaries based on this theorem. Since the rectangle is also a parallelogram, The above theorem can also be stated that area of a parallelogram is equal to the area of rectangle on the same base and between the same parallels. So you have a rectangle ABCD. ABCD is a rectangle. And then on the same base DC, we have another parallelogram. So let the parallelogram be, let us name this vertex of a parallelogram as G. So we have DFGC is a parallelogram. So this is how the parallelogram and a rectangle on the same base. So same base is DC and between the same parallels are again equal in area. The theorem 20, the area of a triangle is half that of a parallelogram on the same base and between the same parallels. So what is given to you? You are given triangle ABC and a parallelogram ABDE. They are on the same base AB and between the same parallels AB and ED. You have to prove that area of ABC is equal to half the area of parallelogram AB. So we are completing this another parallelogram. So we are extending this FD and to F and join BF. So we have now two parallelograms, that ABDE and ABFC. Now just in the previous theorem, we have learned that area of the parallelogram on the same base and between same parallels are equal. So we have area of ABDE is equal to area of ABFC. So since they are on the same base AB and between the same parallels, let this be equation number 1. And now when we look at the parallelogram ABFC, you have BC as a diagonal, and diagonal of a parallelogram divides it into two congruent triangles. So therefore, we get area of ABC is equal to half the area of parallelogram ABFC, because the diagonal of the parallelogram divides it into two congruent triangles. So it becomes half of that. And from 1 and 2, both are equal to ABC. So therefore, ABFC. So therefore, you get area of triangle ABC is equal to half. In place of ABFC, now I can write ABDE, because area of ABDE is equal to ABFC. So it is equal to half of area of ABDE. So hence we have proved the theorem, area of triangle is half the area of a parallelogram on the same base and between the same parallels. Got it? Now, theorem 21, the triangles on the same base and between the same parallels are equal in area. So you have triangle ADB. You are given triangle ABC and triangle ADB. Both are on the same base AB and between the same parallels AB and CF. So you have to prove that area of ABC is equal to area of ABD. So for proving that, let us complete these two parallelograms. So we extend this side parallel. These two CD was parallel to AB. We extend it and we complete the parallelogram ABEC and ABFD, right? At ABEC, you have BC is a diagonal. BC is a diagonal. So we have area of triangle ABC is equal to half the area of parallelogram. The parallelogram, the diagonal of a parallelogram divides two congruent triangles. Area of parallelogram ABEC. This is our equation number 1. Diagonal divides the parallelogram into two congruent triangles. This is how the area is half according to the previous theorem. And area of triangle ABD, area of triangle ABD, wherein now this is BD is the diagonal of ABFD. So area of triangle ABD is half area of parallelogram ABFD. So this is our equation number 2. And the third equation, that is, we have area of ABEC is equal to area of ABFD. This is equation number 3. Because these are the parallelograms on the same base and between the same parallels. So we get from 1, 2 and 3, we get area of triangle ABC is equal to area of triangle ABD. So these proofs we are going to use for solving the problems. Got that? So we did with theorem 21. Now let's understand some corollaries based on these theorems. So parallelograms on the same base and between the same parallels are equal in area. So sorry, same base we have seen. Now it is equal bases. So what does that mean? Let us look at the diagram. So you can see that there are two parallelograms where the bases are equal. So you have AB is equal to EF. The bases are equal and they are between the same parallels. So therefore you have area of ABCD is equal to area of EFGH. EFGH. That is, the parallelograms between same parallels but having equal bases also have equal area. Got that? The next corollary, area of a triangle is half the area of parallelogram if both are on equal basis and between the same parallels. So area of a triangle, this is the triangle ABC, and you have a triangle, you have a parallelogram EFGD. In both of these, you have BC is equal to EF, bases are equal, and they are between the same parallels. And we know that the heights between the of both all the figures are going to be same. So therefore, you have the area of a triangle, area of triangle ABC is going to be half area of parallelogram EFGD. EFGD. That is, if the parallelograms are on equal basis, they are on equal basis and between the same parallels, then area of a triangle is half the area of the parallelogram. Got that? The third corollary, two triangles are equal in area if they are on equal basis and between the same parallel. So we have two triangles where the bases are same, BC is equal to EF, and so you know that the area of triangle is half base into height. The height is going to remain same and the bases are same. So you have the areas of these two triangles are equal. So because they have equal bases and they are between same parallels. Let's start with question number 1. In the given figure, if area of a triangle ADE is 60 centimeters square, state giving the reason the area of parallelogram ABED. So area of a parallelogram ABED is going to be twice area of a triangle ADE. Why ADE? Why twice area of triangle ADE? Because AE is a diagonal and then area, this diagonal is dividing the parallelogram into two congruent triangles. So therefore, area of parallelogram ABED is equal to twice the area of triangle ADE because they are on the same base DE. Got that? Now, so since it is twice, we are already given the area of triangle ADE is equal to 60 centimeters square. So 2 times 60, this is how we get area of parallelogram as 120 centimeters square. The second part, rectangle ABCF. We are asked to find the area of rectangle ABCF giving the reason. Now, area of the parallelogram is equal to area of the rectangle on the same base and on the same altitude. If they have the same altitude, that is, they are lying between the same parallel. So therefore, you have area of rectangle ABCF is equal to area of parallelogram ABED, and which is equal to 120 centimeters square. Now, the third part, we need to find area of ABE. So we know that the area of triangles, just now we have seen the corollaries and the theorems, area of the triangles on the same base and between the same parallel lines are equal. Okay, the areas are equal. So ABE, the base is AB, altitude, and they have equal bases. How the equal bases? Because since it is a parallelogram, opposite sides are equal. So AB is equal to DE, the bases are equal, therefore the areas are equal. Got that? Now let's move on to question number 2. The given figure shows the rectangle ABDC and the parallelogram ABEF drawn on the opposite sides of AB. Prove that CDEF is a parallelogram. Now, CDEF as a parallelogram, we already know that AB is equal to CD. They are the opposite sides of parallelogram ABCD. And we also know that AB is equal to FE. AB is equal to FE. So therefore, since they are the opposite sides of parallelogram, and therefore you have CDEF you have to prove CD. Therefore, you have CD from these two equations. We understand CD is equal to FE. Now, since a pair of opposite sides, and CD is parallel also. CD is parallel to FE. So, since a pair of opposite sides is parallel and equal, we can say that CDEF is a parallelogram. Got that? So we have done with the first part. For the second part, area of a quadrilateral CDEF is equal to area of rectangle ABDC plus area of parallelogram. So we need to prove this second part. So for that, let us extend this part. Let us extend this and let us take this point as x. Let us take this point as x and let us take this point as y. Now we know that FE is parallel to XB. So now we have, and we also know that the parallelograms on the same base and between the same parallels are equal in area. So we have area of parallelogram, which is on the base FE, on the same base FE, which is ABEF is equal to area of the parallelogram um, F E F E Y X. This parallelogram FEYX. Okay, because they are on the same base EF. They are on the same base FE and between the same parallels AB and FE. So they are equal in area. Now second parallelogram ABDC is equal to area of parallelogram XYDC. This parallel, they are on the same base CD and between the same parallels CD and XB. So if we add these two equations, adding these two equations, you get area of parallelogram ABEF plus area of parallelogram ABDC is equal to, when I add these two parallelograms, area of FEYX plus area of XYDC. So FEYX and XYDC together it makes the parallelogram. CDEF. Area of parallelogram CDEF. Got it? So this is how we proved the second question. Moving on to question number 3. In the given figure, diagonals PR and QS. PR and QS of the parallelogram PQ. So you are given a parallelogram PQRS. They intersect at O, at point O, and LM is parallel to PS. So you have LM is parallel to PS. So that is why all the three lines are parallel to one another. So you get two parallelograms over here. So we know that area of a triangle, this is area of triangle POS, and parallelogram PMLS. They are on the same base PS. And between the same parallels, that SP and LM. Therefore, you have area of POS is equal to half area of PMLS. So therefore, twice area of POS or PSO, you get area of PMLS. Got it? The first part. So the twice area of POS is equal to area of PMLS. So we have done with the first part. For the second part, area of triangle POS plus area of triangle QOR is equal to half area of parallelogram PQRS. Now, LM is parallel to PS. LM is parallel to PS and PS is parallel to RQ. So therefore, you have PS is parallel to LM is parallel to RQ. All the three are parallel and therefore you get these two parallelograms. Now, same as in the previous case, we have area of triangle POS is equal to half area of the parallelogram PSLM because they are on the same base PS and between the same parallels PS is parallel to LM. Same way, you have area of QOR. This triangle QOR is this is on the same base RQ, and between the same parallels LM and QR. So therefore, you have area of QR is equal to half. Now, let us add these two equations. So, adding equation 1 and 2, which is what is required here, POS and QOR. So, we do this. This is our equation number 1 and this is equation number 2. So, let us do equation 1 plus equation 2. And doing that, you get area of POS plus area of QR is equal to half of LHS and LHS are added. So, we take half common and we have parallelogram PSLM plus LMQR, and PSLM plus LMQR. Together it is parallelogram PQRS. So this is how we get area of triangle POS plus area of triangle QOR is equal to half area of parallelogram PQRS. Got that? The third part of the question, you have to prove area of POS, triangle POS plus area of triangle QOR is equal to area of POQ plus area of SOR. Now, area of POS is equal to POS is equal to POQ. POS is equal to POQ. Why? Because we know that the diagonals bisect. Diagonals of a parallelogram bisect and PO is a median. PO is a median. And median of a triangle divides it into two congruent triangles. Okay. So this is how we get area of POS is equal to area of POQ. So same way we have area of triangle QOR is equal to area of triangle SOR, where of triangle ROQ or QOR is equal to area of triangle SOR, wherein RO is a median. Diagonals of a parallelogram bisect each other. And median of a triangle divides it into two congruent triangles. So this is how you get area of POS is equal to area of triangle POQ and area of QOR is equal to area of triangle SOR. Now, you are asked to prove, let us add these two equations because it is POS plus QR. So when we add LHS and LHS, we are going to this. So just adding this equation. So if we do equation 1 plus equation 2 and we are done with the proof. So adding these two equations, area of POS plus area of QR is equal to area of POQ plus area of SOR. Got it? Question number 4. In a parallelogram ABCD, P is the point on side AB and Q is the point on side BC. You have to prove that triangle CPD. This is your to prove. You have to write given to prove. So since the place is enough, not enough for me, I am not mentioning. But every time given to prove is must. So what is given to you? You are given a parallelogram ABCD. P is a point on side AB and Q is the point on side BC. You have to prove that triangle CPD and CQD and triangle AQD are equal in area. Okay. So let us join the diagonals. Let us join the diagonals of the this parallelograms. So AC is the diagonal of parallelogram ABCD and then BD is another diagonal. Then area of CPD, this triangle, area of CPD is equal to area of BCD, the area of BCD, because they are on the same base DC and between same parallels AB and DC. Therefore, their areas are equal. Triangles on the same base and between same parallels are equal in area. So here the base is CPD and BCD. You have the same base which is DC. Okay. Next, area of BCD. Area of this BCD is equal to half the area of parallelogram ABCD because BD is a diagonal. BD is a diagonal and diagonal of a parallelogram divides it into two congruent triangles. So therefore, area of BCD, which is the half created because of the diagonal half, it becomes half the area of the entire parallelogram ABCD. Same way, you have area of CPD. Area of CPD is equal to half the area of ABCD because they are on the same base CD, and between same parallels CD and AB. So therefore, you have area of a triangle is half the area of the parallelogram on the same base and between the same parallels. And then area of AQD is equal to area of ABD. AQD is equal to area of ABD because they are on the same base AD. They are on the same base AD. This is on the same base AD. And then it is half. And it is half of the area of the parallelogram. So parallelogram, and they are lying between the same parallels AD and BC. So if the triangle on the same base and between the same parallels, the area of the triangle is half the area of the parallelogram. So two theorems used here. Areas of the triangles on the same base and between the same parallels are equal, and area of a triangle on the same base is equal to half the area of the parallelogram on the same base and between the same parallels. Got that? So from equation 3, now from this is from 3 and 4, from 3 and 4, both of them have ABCD. So this is how you get area of CPD is equal to area of AQD, and we are done with question number 4. Question number 5, you are given a parallelogram. You are given a parallelogram ABCD where M is the midpoint of DC. So these two parts are equal. N is the midpoint of AB. And also you are given area of ABCD is equal to 48 centimeters square. And then you have to find out the area of BEC. So first part, to find the area of BEC. So let us observe this carefully. So BEC, this triangle BEC and parallelogram ABCD, they are on the same base BC. The BC is the same base, and between the same parallels BC and AD, AD or AE, which is being extended. Okay. So therefore, you have area of BC is equal to half the area of parallelogram ABCD. Same base BC and between the same parallels. Got that? Now, since it is half the area, so it is half of the area of ABCD, which was given as 48. So half of 48, which is 24 centimeters square. So we have done with the first part. Name the parallelogram which is equal in area of to triangle BEC. Which parallelogram is equal in area of triangle BEC? So area of ANMD. So this area is equal to area of BNMC. Why? Because N is the midpoint and M is the midpoint. So that is how the equal intercept theorem, these two parallelograms will have equal area. So area of this parallelogram ANMD is equal to area of the parallelogram BNMC, and the parallelograms. And since these parallelograms are equal to half area of ABCD. This is half area of ABCD, and which is, we have already shown here, area of BC is half area of BC. So therefore, the parallelograms ANMD and NBCM, they will have equal areas to triangle BEC. Got it? So children, if you like the video, please share with your friends. Coming up with the next questions or next all questions of exercise 16A. And if you like it, please subscribe. Thank you for watching. Have a good day.